If you have got 3 such containers and you have got a piece of solid, you can keep it here, you can keep it there, you can keep it there. It doesn't care about the empty space. Correct? If you take liquid, if you move it here, it changes its shape. But it doesn't care about the empty space. If you take gas, I have made 20 dots. Still 20 dots. And still 20 dots. See the difference? Gas likes to go everywhere. Gas likes to go everywhere. That is its nature. So what do I say as the volume of the gas? We just say that the volume of the gas is the volume of the container. We don't say that the volume of the gas is the volume of those 20 particles. And by the way, 20 particles is very non-practical. Particles, number of particles, if we talk of, then they could be of the order of 10 to the power 23 or more. 5, 6, 7, 20, 25, that's not the number that in reality shows number of particles. So volume of gas is the volume of the container. You can compress gas. In this board itself, you can see that in the first drawing, gas is somewhat compressed. In others, in the comparison of others, here compression is more. Now just imagine if I make the container even smaller and I still put 20 dots, that would mean that compression is even more. So you can compress it more and more and more and more, which neither the solid likes nor the liquid likes. Gases also have one more property which is quite quick. And that property is diffusion. In simple language, mixing with other gases. Liquids also can mix with other liquids. So diffusion may be there in them also. Imagine ink. You pour a drop of ink in water. Fine. But it's very quick in case of gases. So perfume, smell, from one end you keep the perfume bottle, one end of the room, and in the opposite end, from the opposite end, you are able to smell perfume. Or what about food? Sometimes you know that your favorite thing has been cooked. Food particles are present in air. And food particles that are present in air, they travel distances. So they reach your nostrils. If they refuse to travel distances, if they just live where they were there, in some cooking utensil or whatever, then how would you be able to smell them? So diffusion is rather quick in gases comparatively, in comparison to, say, liquids. Gases mix so well with each other. What we are breathing is a mixture of gases. Mixing may not be as good in others. One piece of solid, another piece of solid, they may just refuse mixing with each other. You make powders for both and then you try to mix. And for liquid, there are certain types of liquids which hate other types of liquids. You know very well that petrol floats over water. That means petrol does not enjoy the company of water. If you have done some painting work using the paint, oil paint, then you would also know that after that work, when your hands have got some oil, washing in water using soap is not very effective. That is because that paint and water are not good friends. They don't blend. And that's why you need something called turpentine. Using turpentine, you are able to clean the oil stains or rather paint stains that are there in your hands. Turpentine and oil are good friends. Water and paint. Paint and turpentine are good friends. Paint and water are not. Water and petrol are not. Water and kerosene are not. So diffusion is there in liquids, but there is a general rule that is obeyed, and that general rule is like dissolves like. Like dissolves like. In fact, why does soap work at all? How are we able to clean clothes using detergents? That itself, detergent itself works on the principle of like dissolves like. Detergent itself works on the principle of like dissolves like. I guess there was some UPS problem. In case of gases, the diffusion is excellent. So gases mix with each other extremely well. Now, when we say that gases can be compressed rather easily, then it clearly means that the distance between the particles is large. Distances between the particles are large. There may be several particles, as I said. Order could be of in the range of 10 to the power 23, and much more than that is possible also. Distances are rather large in case of gases, and particles are haphazard, moving here and there. Very disorderly type of behavior you would find in case of gases. In case of liquids, also here and there motion is possible, and distance is not as large as it is in case of two gas particles. So two gas particles if you take and two liquid particles if you take, then you would find that distance between the liquid particles is less, and distance between the two gas particles is more. Talking about solid, the distance will be the least in case of solid, and also arrangement will be quite nice in case of solid. Arrangement of particles will be quite nice in case of solid. Not haphazard here and there, but in a very disciplined manner the particles will be in solid. But that does not mean that there would be no motion at all. Motion inside the solid may not be visible to our eyes, but there is bound to be some thermal energy. There is bound to be some vibration here and there, and that our eyes do not detect. This thing which is there in liquids and gases, that particles can move from one point to the other point, that is the fluidity. And that's why the word fluid either means gas or liquid. Okay? This is for you to try out. Increasing order. So which has the least density? You keep on telling me and I keep on typing it. Least density.
Sir, air.
Air. Then
Exhaust from chimney. Sir, exhaust from chimney. Sir, exhaust from chimney.
next.
Water. Water.
Okay.
Then honey.
Honey.
Yes. Cotton.
Cotton.
Chalk. And iron.
That's perfect. Any questions regarding this? Let me know. Okay. What's the reason?
Sir, in gases, molecules move very randomly, so they fill.
Molecules move randomly, then
Sir, so they fill the vessel
Sir, a
completely.
gas does not have definite volume, so it occupies the whole container.
it occupies the whole container. Okay. You can also add that in gas, the interparticle forces are very weak. So there is nobody really to discipline the particles or bind the particles. So they are completely on their own. So they travel anywhere, and that's how they are able to complete, they are able to cover. They are able to cover the whole region which is available. And that's not the case in case of liquids and solids. Others are pulling other particles. Other particles are pulling other particles all the time. Now, before I put up the next question, I need to give some explanation. Concept of gas pressure. Concept of gas pressure. If you look at the tire of car or a motorbike or cycle, then it is supposed to be having certain pressure. It is supposed to be having certain pressure. What it means is that air inside it is supposed to be having some pressure. What is the meaning of pressure in the context of gas? What is pressure? Pressure is force divided by area. Pressure is force divided by area. Just imagine that you have got a nail and there's a wall, and you've got a hammer, nail, and wall. Why does a nail have a very thin area? Why is it not broad? Why does it have a thin area at the tip?
Sir,
Sir,
The reason is,
sir,
yes. Yes, go ahead.
sir, when area is less, the pressure will be more, so it can pierce inside.
No.
Sir,
You
if
are,
the pressure varies inversely with area, sir. So
Yes,
less the area,
yes.
more the pressure.
Yes, that's the answer. Force, whatever force you are applying, force is more or less that you decide. How hard are you going to bang? You decide that. How much force are you going to apply? The question is of pressure. So if pressure is force divided by area, mathematics tells you that if you divide something by a small number, that thing becomes big. Take anything that comes to your mind, any number. Divide that number by a very small number and see what happens to that number. Take 10 for example. Divide it by 0.1. How much does it become when you divide it by 0.1?
Sir, 100.
It becomes 100. So whatever force you are applying, if area is small, then force divided by that small area will be large. Pressure is large. Okay, now that's about just the definition of pressure. But in the context of gas, if I can have larger force, I can have larger pressure. Yes, if I have small area, then also I can have larger pressure. To have larger pressure, I have got two choices. Either I increase force or I decrease area. Suppose the vessel is fixed. If vessel is fixed, its all walls are fixed. I cannot change the area of the walls of the vessel. Now I can change force, but I can't change the vessel. Suppose that is the condition we are having and the gas is inside the vessel. Right? All sides are fixed, areas are fixed of all the sides. Force. You might have experienced that sometimes on rare occasions the tire bursts. What if the pressure is too much inside the tires? What if the pressure is too much inside the tire? Your common sense will say that the tire might burst. Now I'm talking about the meaning of pressure in the context of gas. Gas has got several particles, several means of the order of 10 to the power 23 and much more than that. These particles are going here and there. Right, left, up, down, all random directions. When these particles hit the wall or hit the walls, there are 6 walls, let's say, then they bounce back. Have you ever taken a ball and hit the glass of some, say, window with it? If not intentionally, maybe unintentionally, or you might have seen somebody doing it accidentally. Ball hitting the glass of the window and breaking down the glass. You, if not have seen it, would have heard about it, or your common sense would say that yes, it happens. Right? Just think of gas particles as the balls. And imagine those walls of the vessel as glasses on the window. Ball hits the glass, the particles of the gas hit the walls of the vessel. The rest is physics. Rest is physics. What Newton's second law it is. Newton's second law says that when there is change of momentum, then you have got force. Force is the rate of change of momentum. So when a ball hits the glass, that's exactly what happens. Momentum changes. When gas particles hit the vessel walls, exactly the same thing happens. Momentum changes. I think we'll be talking more about momentum, Newton's law, etc. in physics. At this point of time, you just visualize that a particle comes, hits the wall and rebounds, hits another wall, rebounds, like carom board, billiards, etc. So when you play carom, by the way, then the side walls do experience force. Side walls. Billiards, same story. Side walls do experience force. Whenever your ball hits the side walls, they experience force. So that is why so many particles of the gas are going here and there, banging the vessel walls. There is force. And pressure is force per unit area. Right? So that's the meaning of pressure when we talk of gas. So when you see that in a petrol pump some tire is being filled, then there would be some reading there, and that instrument would say that the pressure should be so and so. Not more than that, not less than that also. So that pressure inside the tire means that pressure of the air inside the tire. So in the context of tire, just replace the vessel walls by the tire walls or tube walls. There are tubeless tires also available these days. So whether it is tube inside the tire or there is no tube at all, directly tire having air. It is the air inside that has that much pressure. Now coming to the next question. Explain, how does a gas, how does it exert pressure on the walls? Yes.
Sir, when the particles hit the walls of the container, they also exert a force while doing so. That's why, in that process, they exert pressure on the container, like in the tire. There are many particles and they hit the tire, and many of them hit the particles, hit the tire at the same time. So the tire stays in its position, like in one particular shape. That's how they exert pressure on the container.
Now tell me, do they rebound after hitting the tire or walls, whatever? Do they rebound? Do they rebound or not?
Yes,
the answer
sir.
is yes. Yes. And I took one word, one physical quantity. I said force is equal to rate of change of something. What was that thing?
Momentum.
Momentum. Yes. So force is there because momentum is changing, and pressure is there because there is force. So pressure because of force because of change in momentum taking place. That should be easy. Why should we call wooden table solid? Yes.
They have definite shape.
Definite
They
shape.
have definite volume.
Anything more?
Volume.
Specific volume.
The volume, shape, fine. Now I'll give you a tough question to think about. But I will give you the clue also. Now before I give you the clue, that's your assignment question. Part D is your assignment question. And regarding the clue, look at the forum.